Let's learn about buffers. So, your body has to maintain a pH of 7.4. In order for this to happen, you have to have something in your body that would react with an acid or a base to keep it from changing pH. That is called the buffer. So, what is a buffer? A buffer is a solution that keeps the pH from changing. In your blood, you have the carbonic acid and the bicarbonate ion buffer. So here, this is the acid and this is the conjugate base. If you add a base to your system, then this acid will react. If you add an acid to your system, then this base will react. Therefore, whatever you add to your system, this acid-base buffer will keep the pH from changing, and then it will stay at pH 7.4. So here's a definition. A buffer lessens the impact on pH for the addition of acid or base, so the pH stays the same. Here's an example drawing. Here we have the pH of, let's say your solution has a pH of 5.0. Here we're adding drops of H+. This is HCl. As they add the HCl in here and they kept recording the pH is staying around 5. That's because there's a buffer in the solution. Now, what if we added some NaOH solution into the beaker? As you can see, the pH is still around 5. The pH did not change. So you might wonder, I wonder what they have in the solution. What is in the buffer? Okay, so here's an example. Let's draw a beaker. What would you put in a beaker to make a buffer? First, you have to know what you're doing. What you're doing is, if you have H+, you want something in the beaker that would remove the H+. What do you think will remove the H+? That's correct, some OH-. So as soon as you add the H+, the OH- will react with it and neutralize it. Okay? So in your beaker, you better put some OH-. Well, what if you add some OH-? You have to have something in the beaker that will react with that. Why don't we put some H+? So when you add the OH-, the H+ reacts with it and it goes away. So this cancels with this cancels with this, and you have a neutral solution. Okay, so to put OH- in your beaker, you would have to put it in the form of NaOH. The Na+ will be the spectator, and here you would put HCl, and the Cl- would be the spectator ion. So these two won't really do anything. Let's just ignore it. So what you're saying is, to make a buffer, make sure you put an acid in the buffer to react with the base, and you put a base in the buffer to react with the added acid. Okay, but there's a problem. Okay, so let's say to make a buffer, put NaOH and HCl in a beaker. Okay, but this will not work. It won't work. Can you guess why it won't work? It won't work because they will react with each other first, even before you add these two right here. Okay, so if you put NaOH and HCl, what do you really have? You're going to have salty water. Will salty water act as a buffer? Water will not act as a buffer. As soon as you add the OH-, the pH will go up. So what do you put? What the trick is, you need to put an acid and a base in the beaker, but they cannot react with each other. So why don't you put a weak acid, H2CO3, and its conjugate base, HCO3-. Let's see how that works, okay? So if you add OH-, which of these two will react with OH-? That's correct. This will react with one of the H's. So then the pH won't change. What if you add H plus to it? Which of these two will react with that? That's correct. This will bond with this, and the pH won't change. Okay? But the question is, will these two neutralize each other? No, they won't, because it's the conjugate pairs. So that's how you make a buffer. To make a buffer, you need to add a weak acid. To make a buffer, add a weak acid and its conjugate. Okay. Also, the reason why it has to be a weak acid, if that's a weak acid, that means its conjugate base is strong enough to get the H pluses. Okay, let's see another example. Let's say you put HCl and its conjugate. Let's say you drop in some OH minus. Will HCl neutralize it? It will. What if you drop in some H pluses? Will this conjugate base react with that H plus? No, because it doesn't want it. So you cannot have anything strong, a strong acid or a strong base, in your buffer. Okay, so the bottom line. To make a buffer, it's true, all of the following statements describe a buffer except, does a buffer resist change in pH? That's correct. Is a buffer as a solution containing almost equal amounts of strong acid and its conjugate base? No, you can't have strong acid because the conjugate base will be too weak. A solution containing almost equal amounts of weak acid and its conjugate. That's correct. C is the choice. And A and C. Okay. You can also have a weak base and its conjugate. Either one will work. But one of them has to be weak for the other one to be strong. Okay. Which of the following would make a good buffer? Why or why not? So go ahead and pause the video and choose. Letter A. Nope. You cannot have any strong acid. You cannot have any strong acid. You can't have strong bases. This is a weak acid and its conjugate. So yes. Okay. This one, so C is an answer. This one is a weak acid. It's not one of the top 7. So it's a weak acid. But this is not a conjugate. The definition of a conjugate is different by 1 H. These are different by 2 H's. So no, cannot use that one either. So the answer is just C.